In this video, we're going to talk about the various types of functions that exist. So this is considered a library of functions. We're going to start with a very basic function, which is called the constant function. So the constant function starts with f of x equals b, a constant. B can be any value, any real value. Okay, so just to give you an example, one such example could be f of x equals, let's just say 2. So if we were to make a table of all x values with their corresponding f of x values, we would say x could be -2 and f of x would still be 2. X could be -1, f of x would still be 2, 0 would still be 2, 1 would still be 2. You get the pattern. All right, so what this produces on the graph would actually be a horizontal line at 2. All right, so think domain and range. The domain for this will actually be -infinity to +infinity. The range, however, is simply going to be that value b. So for my specific example, the range will just be 2. And again, this is in interval notation. The second function is the identity function. The identity function is represented as f of x is equal to x. Now, if I were to make a table for this, I would have the x values and the corresponding f of x values. And if I have -1, my output will be -1. If I have, let's say, 0 as my input, x, then 0 will be my output. If I have +1 for my input, +1 would be my output, 2 and 2, and so on and so forth. So you get the pattern, and that's why it's called the identity function. Whatever your input will be, your output is the same exact value. This produces a diagonal line that intersects the origin. Okay, so the domain of the identity function will be -infinity to +infinity. The range is also -infinity to +infinity. A couple more things to keep note of. Since this is a linear function, we can identify the slope. So the slope, which is m, is equal to 1, or 1 over 1. You rise 1 and you run 1. The y-intercept is going to be 0, the origin in this case. The third function is the square function, or you could consider this the most basic quadratic function. This function is represented as f of x is equal to x squared. So again, writing the table, this would be x and f of x. Let's start with -2. The output will be 4. -1, the output's 1. 0 is 0. 1 is 1. And 2 is 4 again. So notice that there is some symmetry here. And this actually, when you graph it, produces a parabola. Okay? Domain will be -infinity to infinity. And the range, in this case, is actually 0, including 0 to infinity. A couple other characteristics. You'll notice that this is symmetric with respect to the y-axis, which means that this is an even function. Okay, other note is that the intercept is the origin 0, 0. Finally, we also know that it's increasing for the interval 0 to infinity, and it's decreasing from -infinity to 0. Finally, the last thing I'll note is that the shape of this graph happens to have a special name, and it's called a parabola. The fourth function happens to be the absolute value function, and the absolute value function is represented as f of x is equal to absolute value of x. All right, so again, making a table, we have our x values and we have our f of x values. So we have -2, -1, 0, 1, and 2. The output for -2 is +2. Output for -1 is 1, and we have 0, 1, and 2. So again, notice some symmetry here. In this case, what we have are two rays, if I could ever draw them straight. It's a shape of a V, and it should be looking a lot nicer than that. But it is the shape of a V, and it is some symmetry. And it happens to be actually two rays where the endpoints of these two rays intersect at the origin 0, 0. So, domain. Likewise with the parabola, there's actually going to be some similar characteristics here. It's going to be -infinity to infinity. And the range, likewise with the parabola, will be from 0 to infinity. All right, you'll notice this is also an even function. You'll notice that the intercepts are 0, 0, the origin, that it's increasing from 0 to infinity and decreasing from -infinity to 0. Finally, our last function is called the cube function. Cube function is f of x is equal to x cubed. So again, making a table, if we have, let's say, -2, -1, 0, 1, and 2, the output will be -8, -1, 0, 1, and 8. You'll notice there is some symmetry with this, but it's not the same symmetry we saw with the last couple. So if we were to graph this, we actually see that the graph looks something like this, if I can draw it well. It's going to come down, it's going to intersect the origin and snake down this way. Okay, so there is some symmetry. We'll get to that in a minute. First of all, domain. Well, the domain happens to be, again, -infinity to +infinity. The range will be -infinity to +infinity, all real numbers as well. Okay, a couple other different thoughts with this. First of all, it has an intercept. So the intercept is 0, 0. We know that it's increasing for the entire function. It will be increasing. So it's actually increasing from -infinity to +infinity. Finally, we know one more thing about this function, and that is the fact that it is actually an odd function. So it is symmetric, but it's symmetric with respect to the origin.
Excellent.